We left off last time talking about different methods for finding least common multiple. And the one that we had just discussed, and I'll discuss it once more briefly before we move on, was the division by primes. And we had filled in the details about how to do division by primes, writing the numbers in a row, dividing by common factors. We talked about a couple of differences with doing this with greatest common multiples, or did I say that right? Greatest common divisors, excuse me. And we just have to have, if we have more than two numbers, we have to find anything in common to at least two of them, and then multiplying more than we originally had together. So let's see an example. We have least common multiple we're supposed to be finding of 90, 100, and 20. And so what we're going to do is we're going to write those numbers all on a single row. So here's the 90, here's 100, and here's 20. And we're looking for, and it really is division by primes, so we're supposed to divide by primes. So what is one prime number that will go into both of them? Either the smallest or not the smallest, it doesn't matter. 5. Okay. 10's not prime. Technically it won't give us a wrong answer, but it says division by primes, so we'll stick with the primes for it. 5 will work. What is 90 divided by 5? Okay, I'm going to try something different because I'm not sure that you guys are going to do that one in your head. How about if we do by 2 first? I think we make it smaller but easier. 90 divided by 2. 45, that's a good one. How about 100 divided by 2? 50. And 20 divided by 2? 10. Fabulous. All right, now let's divide by 5s because I think those are smaller. We actually know our 5s table's that big. 45 divided by 5. 9. 50 divided by 5. And 10 divided by 5? 2. Okay, so what we do next is we recognize, we should all recognize that 9, 10, and 2 don't all have a common factor, right? That's okay. Do at least 2 of them have a common factor? Yeah. 10 and 2 still have a common factor of 2. So we're going to divide that out. And the part that doesn't have the common factor, namely the 9, it just comes down. Okay, so this is really not division anymore, right? Because we did not divide the 9 by the 2, and I know that. But the process that we're doing will still give us a correct answer here. What about 10 divided by 2 then? 5, and 2 divided by 2 is 1. And when we're looking at the 9, 5, and the 1, do they have any other common factors between any of the two of them? No. And then our answer ends up being the product of everything along the side and the bottom. That will give us the least common multiple. So we have 2 times 5 times 2 times 9 times 5, and then technically times 1. I don't need to factor this or anything like that. I'm not interested in trying to find the prime factorization form. I'm interested in finding the value that we get when we multiply back out. So if you multiply these back out, what do you get? 900. So the least common multiple of 90, 100, and 20 is 900.
So when you write our answers, do you want us to write, I know like last week we were doing LCM, and then we were writing like 90,
You can. I'm more concerned that you just know what it means when you see it.
Okay.
So you could, I mean, it would be fine, of course, for you to write more distinctly, and I'll write it on the next one because of the type of problem that it is, that the LCM of 90, 100, and 20 is the 900. But unless there's like a distinguishing factor between them, like you're trying to identify between, you know, two different answers of LCMs in a particular problem or something, you don't have to write it out. Okay, there is a formula that once you find one will automatically give you the other one between the greatest common divisors and the least common multiples. So the formula says that the greatest common divisor times the least common multiple equals the two numbers multiplied together. And you do need to notice that this is a relationship only when you're comparing two numbers, not 3 or 4. So I couldn't use that last example and do this for this formula because the last example had 3 factors or 3 values that I was trying to find the least common multiple of. Okay. So no matter what the numbers are, their least common multiple times their greatest common divisor multiplied together will give you the product of the two numbers. It's kind of a cool feature. And what I'd like for you to do in the example that I have is to take a look back at one that we've done before. We found the least common, or we found the greatest common divisor in example 4 of 72 and 126. So flip back for me in your notes, and I would like for you to find what is the greatest common divisor of 72 and 126. It is 18. Okay? So we're just getting that from a previous problem. We're not recreating the fact. What we're trying to do is we're trying to use this fact to find the least common multiple. So it is supposed to be true that the greatest common divisor times the least common multiple equals the two numbers multiplied together. Well, our two numbers are what? 72 and 126. And our greatest common divisor from previous work we know is 18. So the only thing I don't know is the least common multiple. So how can I find it using these facts on the screen? Yep, multiply the 72 and the 126, and then Amy said divide by the 18, and that's exactly right. So if you multiply, we'll do it in 2 steps, just because. If you multiply the 72 and the 126, what do you get? 9,000 what?
72.
Okay, I don't have that number written down. 9,072. And then I need to divide by the 18.
You get 504.
So the least common multiple we're finding is 504. It would be a good idea to make sure it's really a multiple. How could you check that part? Just as a quick check.
Divide by 72.
Just make sure that when you do 504 and divide by 72, you get a whole number. And when you do 504 and you divide by 126, you get a whole number. Now, that doesn't guarantee you that it's the least common multiple, but at least it guaranteed you found a common multiple, right? And that's half of the problem. So you've got a quick check to find out if you did a portion of it correctly, if it's a reasonable answer. All right, I've got a couple of examples for you, content like real-life examples of greatest common divisors, least common multiples, okay? So we're going to take a look at those next. 2 bike riders ride around a circular path. The first rider completes 1 round in 12 minutes. The second rider completes 1 round in 15 minutes. If they both start at the same place, the same time, going the same direction, and all of those features are necessary here. If they started at different times, if they were going different directions, or if they started at different places, this wouldn't work. Okay? And they're going at a consistent pace. Those of you who run or bike or anything know that that's not a very easy thing to consistently pace yourself. But these particular bike riders are consistently paced. Okay? After how many minutes will they meet again at the starting place? So they're going to cross paths with each other along the path at some point too, because they're just running around the track, okay, over and over and over again. Well, in this case, they're doing a bike around the track. But they're going to cross paths at some point, potentially out in the middle of somewhere else. But we're actually talking about starting at the starting line when they're going to cross paths again, okay? The question you have to ask yourself on each one of these content type questions is this a least common multiple or a greatest common divisor question? It is the least common multiple. Do you know, or can you justify why, Ariel?
I just had it. After how many minutes will they meet again at the same place? Well, you're not really trying to find. You're trying to find how many times of those two numbers until they meet up again.
Mm-hmm.
Yeah, I don't know.
Yeah, I mean, we're trying to figure out, so they're not going to meet up in 12 or 15 minutes, right? And it's certainly not going to be anything smaller than that, which would be a greatest common divisor answer, correct? We're trying to find out when they're going to meet up, and it's going to be more than the numbers we're talking about. So it's going to be a multiple of the numbers we're talking about. So person number 1 goes around once in 12 minutes, twice they go around 24, 3 times they go around 36, and so forth. Person number 2 does 15, and then they do 30, and then they do 45, and so forth. Those are multiples that we're listing out. This is a least common multiple question. So the question then becomes, how do you want to find the answer? And there's no specific right or wrong way. We've done lists, we've done factor trees, we've done division by primes. What do you want to do to find the least common multiple of these two values?
The intersection.
You want to do the intersection, so you want to make lists?
Yeah.
Okay. So if we make lists, we're going to list out, and sometimes that's a super fast way to do it, and sometimes it's not. It just depends on the numbers. And if you start down this track and you decide after a few numbers that it's not very fast, you're welcome to change directions, right? Do something different. All right, so I've listed a few of them out loud. I said 12, 24, 36. What would the next one be after 36? 48. And I know that I should keep going at least until I get a 5 at the end of the number. Agreed? Okay. Or a 0 potentially, because I have the 15. That's true. So what's after 48? 60. So that's a 0 at the end. So let's pause there for a minute and see if I can get to that point with 15. 15 and then 30 and then so I did get that number with a very relatively small number of iterations, right? 60. So let's make sure we answer the question asked, because they could be asking us how many laps that the kids have each done, right? And they didn't. So we do need to be careful. They asked us how many minutes, after how many minutes will they meet at the starting place at the same time? And the answer is 60 minutes. I'm so glad you guys even said the word minutes. That's fantastic. There are units on the problem. The answer is 60 minutes. Okay.
On these questions,
Yep.
Is it possible that they might ask us to do a specific way, or can we just pick whichever way we want?
I don't think they ask you to do anything specific, if I'm remembering right from the homeworks, and I would not ask you on a test to do it, because my concern really is more about, can you identify which method you're supposed to be doing, and then can you do something to find the right answer? Yeah.
If they were like asking for like how many laps, would we just count how many numbers?
Yeah, you would. The first rider did 1, 2, 3, 4, 5 laps, right? And then the second one did 4, and those answers would have to be different, because otherwise they would have been going at the same speed, and we knew they weren't. So yeah, you could be asked how many laps that they each rode at that point. And those numbers would have to be different. Yeah, so you have 2 answers. All right, next one. Dr. Hands makes cupcakes for her students, and I haven't done this yet, but I promise I'm going to. Some of you are like, yeah, come on, we've done this before. All right, she wants to make 20 chocolate cupcakes and 24 vanilla. I'm sorry, she makes 20 chocolate and 24 vanilla. She wants to display them on plates with the same number of cupcakes on each plate, but only one type of cupcake on each plate. What is the greatest number of cupcakes she can put on each plate? So first question is this greatest common divisor or least common multiple? Greatest common divisor, because we're trying to divide the cupcakes among plates, correct? Yeah. This is a GCD problem. So we're finding the greatest common divisor of 20 and 24. And I know we could make a list, but since we just did the listing method or a similar version to it on the last one, let's do this one differently. What would you like to do on this one to find the answer?
We factor it.
Factor it, like a factor, prime factorization or division by primes, because both of those factor.
Factorization.
Prime factorization. Okay, so if we take the number 20, you can do a tree or you can do this division algorithm either way. What is the number 20's smallest prime factor that goes into it? 2. And that gives us 10. And then what we would do is 2, and we would get 5, and we're done. So this is 2 squared times 5. Now we'll do the same thing with 24. Smallest prime factor, 2, giving us 12, divides by, giving us, divides by, giving us 3. So this one is 2 cubed times 3. If you'll remember, for GCD, we're looking at what primes do they have in common, and the answer to that would be 2. And what is the smallest number of them? 2 squared. Yes, it'd be squared, yeah. So 2 to the 2 or 2 squared, which is the number 4. So this would be 4 cupcakes per plate. Now notice, that does not mean we have the same number of plates of chocolate and vanilla, right? How many plates of chocolate cupcakes are we going to have? 5. How many plates of vanilla are we going to have? 6. Okay, so you're not going to get the same number of plates doing this, but you are going to get the same number on each plate. All right? This is like doing our trees in rows, right? We could do our cupcakes in rows and do the same kind of thing if you're thinking about a bakery, display cabinet or something like that.